All right, welcome to another exciting edition of the Sonoran Sky podcast. I am your host for today. I'm meteorologist Pete Mangione. I am one of many members on the First Alert Weather team, and I am joined right now by Katrina Bossert. Bossert, did I say that right?
Yeah.
Yes. And you're going to talk today about all kinds of fun things in terms of space and northern lights. Can you tell me what your title is at ASU? I was going to attempt it myself, but I didn't want to butcher it, so go ahead.
I'm currently an assistant professor in the School of Earth and Space Exploration and School of Mathematical and Statistical Sciences. I consider myself a space physicist and also an engineer and make instruments to measure things about space and the upper atmosphere.
Very cool. And just a little bit of behind-the-scenes knowledge, which we were just talking about. So my very first appearance at this TV station about a year ago was an interview with you. And I remember them telling me, Pete, you're going to do something on the Northern Lights, and you're going to talk to Katrina, and she's going to pop up behind you on a monitor. And I was pretty nervous, but because you handled the interview so well and you gave me a lot of good answers, I think it helped me through the process. So thank you for that help with my first on-air appearance a year ago.
Well, thanks for the opportunity to talk about the Northern Lights.
Absolutely. Okay, so basically, your name always comes to mind when I get questions about the Northern Lights. Can we see them tonight? Can we see them next week? Because you're the expert that I always turn to. And first of all, just tell me about yourself. How did you get interested in space? And where did you grow up? Where did you study?
Yeah. So I mostly grew up in Colorado, and I was very interested in the Earth, but also loved lasers and radar. So I pursued studying the Earth some way with instrumentation, and did my undergraduate and PhD at University of Colorado, electrical engineering and then aerospace engineering, and specifically applying that engineering knowledge to the aerospace environment.
And I also grew up in Denver, and when you arrived here to show up for this taping, you called me on your cell phone, and I saw it was a 303 area code, and I had not received a 303 area code call in so long. I thought it was junk. Fortunately, I realized it was not junk and it was you, but yeah, I mean, Colorado is just a beautiful area to explore things like space and study it, right?
Yeah, it is. And then after I graduated, I went on to Fairbanks, Alaska, an assistant professor at University of Alaska Fairbanks. And wow, I mean, talk about space weather. That's you're in it there. Lots of aurora there, and a lot of space physics programs at the University of Alaska Fairbanks as well.
And how long did you live in Fairbanks?
About 2 years.
Yeah. And what's it like living there? Does it ever feel like isolating, or is it just so beautiful and you're focused so much on what you're studying that you enjoy it?
Oh, I mean, it's definitely out there in the middle of nowhere. It takes a while to get there for sure. Yeah, I mean, sometimes it is isolating, and you know, something that also is relevant too, as we're going to bring up our space environment, is all these constellations with giving internet to people. Fairbanks is one of those places where it's really hard to get internet access, and so you know, it's really out there in the middle of nowhere. Yeah, but the aurora up there are beautiful. It's great for that aspect.
I'm
really,
sure.
Yeah.
So, okay, speaking of the aurora, you know, I forecast the weather, which I find challenging. Is it hard to forecast here in Arizona when we're actually going to be able to see the Northern Lights? Because you'll see social media go crazy.
Oh, yeah.
Hey, Northern Lights, and then you'll see all different kinds of maps from different experts. You can see it here, you can see it there. Is that a challenge to try to sort of figure out, hey, can we get views of this here in Arizona?
Yeah, especially this far south. I mean, usually when we get aurora this far south, it's just kind of a random thing that happens where the Earth's magnetic field happens to be displaced so much, you get this random stray particle precipitation this far south. But it's also really difficult just in general to predict how strong a geomagnetic storm is going to be. We can get an idea based on measurements of the sun. So if we see a coronal mass ejection and see how fast it's coming off of the sun and see that mass, based on the models that have been developed at NOAA and the sun's rotation, we can make a prediction. Is that going to hit Earth or not? Approximately how long it's going to take. But we don't know all the parameters. So we don't know the exact density of the plasma. And we don't necessarily know exactly how fast it's moving or the magnetic field associated with the plasma. And that's a big one because depending on how that plasma is oriented, we don't know exactly how it's going to interact with Earth's magnetic field until it gets here. And so that's a factor where it's because there are so many tiny little details. And when we're talking about aurora this far south, we just don't have the modeling capability right now to say, yes, we're going to see aurora at 11 p.m. in Arizona.
And do people ever give you a hard time? Because I will tell you from personal experience, when I'm trying to make a forecast for a monsoon thunderstorm and it does not materialize, people will give me a hard time on email and other forms of social media. Hey, you said it was going to rain. Do people ever do that to you? Hey, where are the northern lights, Katrina? I thought you said this would be beautiful.
Yeah, I think that's a common thing. Everyone gets all excited, especially from that big the big storm that happened last year in May. People see pictures online and they're like, "Oh, we're going to see this aurora overhead." But I did happen to see it in South Phoenix this past October, and I remember pointing it out to some people walking by and saying, "That's aurora." And they're like, "What? What? That I don't see. It just looks like a cloud." Like, yeah, when you're this far south, it's not as exciting. And again, it's always hard because we might get 5 or 10 minutes of an auroral display, and people expect to go outside and see the aurora all night, and you have to be really patient. And yeah, so it can be a letdown sometimes when there's all this hype and then you don't see anything.
Although I will say, based on my experience with your advice, your forecasts tend to pan out. I mean, I think it was back in May, you said, hey, we have a good chance of seeing the northern lights tonight. And the next morning, there were just all these beautiful pictures that came into our Facebook page.
Yeah. And I mean, so that prediction was made by the Space Weather Prediction Center. They were like, we saw this huge multiple ejections from the sun. They knew that it was going to be big. They could see that was coming really fast. And so we knew it was going to be a pretty big storm. Now, as to whether we would get to see aurora or not, that's always kind of hard. I think the people that drove a little bit north of Phoenix had a little bit more luck. I did not have luck that time. But then there are times where we have seen aurora in Arizona and it came out of nowhere. So there's something known as a stealth coronal mass ejection, where you can't see the coronal mass ejection off of the side of the sun. It's coming kind of straight off the sun, and because that density is so much lower than the sun's atmosphere, we just don't have the instrumentation to detect it. So I think it was March and April of 2023, we had 2 times where people were taking pictures of aurora in Arizona, and this was one of those was completely unexpected. We did not know until that massive plasma hit Earth and the outer magnetic field that was happening.
And just so I can remember this, so I can impress people, when I'm at a cocktail party or something, it's called a stealth CME, a stealth coronal mass ejection.
A stealth CME.
Okay, and that's basically the surprise ones.
Yes, the surprise ones. Yes, you can have CMEs that just come off the sun. There's no solar flare associated with them, and they just quietly happen.
Interesting. Okay, now shifting gears a bit, I know that you're very interested in space junk, and I think a lot of people are interested in that. Do you have any things that you want to discuss about that? Because we get questions about this all the time.
Oh yeah. So I mean, I love geospace. That's kind of one of the areas I study. I like studying the thermosphere, ionosphere region, and this is what we call the low Earth orbit region. So there's a lot of excitement about this region because there's all sorts of stuff you can do with satellites and satellite constellations. I think space junk has gotten some specific attention more recently because of the Cosmos 482 spacecraft. And to put things into perspective, right, we knew that it was there. And it launched in 1972. It got a little bit more attention because it was designed to withstand Venus's atmosphere. So there was concern that, this could come down through Earth's atmosphere. Instead of burning up like a lot of space debris does, it can hit Earth. Now, of course, there's a very small chance that it would have cause damage or hurt someone because Earth is so huge. In fact, it crashed down into the Indian Ocean on May 10th. But if you look at 3 days out, right, there were several different models that were trying to predict the time. None of them had the exact agreement on time, and some of the error bars were plus or minus 20 hours on some of these. And I think that puts things into perspective. So in this case, we didn't know the exact state of the satellite, so it's harder to predict drag. But we also know so little about the thermosphere and the variability in that region that it's really difficult to track space debris. I mean, we have trouble predicting solar weather and what the sun is doing more than a few days in advance. I mean, we can say, okay, it's solar maximum or solar minimum, or there's some active regions on the sun, but it's really difficult to tell how much activity is coming towards Earth, and that heats up the thermosphere and causes increased drag for satellites. But we also have this added aspect where the Earth's weather itself. So, you know, you're a meteorologist, you're going to tell us about things like monsoons and thunderstorms. Those things actually influence the thermosphere. So we see those effects in the thermosphere, things like the polar vortex, jets, fronts, really strong convection and thunderstorms. Those also influence density and movement in the thermosphere as well. And right now our models are pretty basic when it comes to that. And so it's very difficult to predict how the thermospheric density is changing and how that's going to affect satellite orbits.
So interesting how weather plays into all of this stuff, and how much like we use weather models, you use your own models to track things like this, and there is some overlap.
Yeah, and there's, you know, kind of the long-term excitement is, well, maybe we can really start to join weather models with thermospheric and near space models at some point, you know. But there's, you know, there's difficulty with that, with, you know, computing power and getting the models to talk to each other. But yeah, there's definitely, like, it's all linked, you know.
And I think you mentioned when we were corresponding last week before this podcast, something about, I can't remember the name of the space station. I think it's in California, and how there's a lot of interest here in Arizona about that.
Oh, yeah. You know, it's so we're probably going to be seeing a lot of launches, especially from SpaceX or from Vandenberg Air Force Base. A lot of the launches can come over Arizona. And the ones that are really fun to look for are the ones that are taking place kind of just after the sun has set. So
you said it's from Vandenberg?
Yeah, Vandenberg
Okay.
Air Force Base.
Yep.
And you can see, you know, when it's dark enough, you can see this glint. So the sun is still reflecting off of the cloud that comes from the spacecraft. The launches look really neat. You know, every now and then you might get to see something like this over Arizona. And I want to point out right now, geospace, our low Earth orbit region, is becoming very populated. Right now we have a little over 11,000 functional satellites in low Earth orbit. But with this excitement about mega constellations, you know, internet that comes from satellites, we're looking at possibly in the next 5 to 10 years having up to 100,000 satellites in this region. So that's a lot of launches that you could see from Arizona, but also a lot of population in our low Earth orbit region.
Is that something people should be concerned about? Like, you know, like a traffic jam?
A little bit. So let's put some things into perspective with space debris, right? So right now, you know, I mentioned we just have 11,000 satellites. We've probably got 14,000 satellites orbiting, but 11,000 of those are functional. When we start to talk about space debris, these numbers get larger and larger. So, you know, again, before I say these numbers, this is a huge environment that we're talking about. It's not like, oh, we're going to launch and I don't know if it's going to be clear or something. It's more of a probability of these things are orbiting for several years. Space debris could be a problem. So when we talk about objects that are greater than 10 centimeters, we've got about 54,000 objects orbiting Earth. When we talk about objects between 1 centimeter and 10 centimeters, that number goes up to 1 million objects. And when we talk about 1 millimeter to 1 centimeter, so tiny like pebbles, grains of sand, over 100 million. I think I saw 140 million objects. Now, that seems small, but to put things in perspective, right, a bullet travels at 600 to 2,000 miles per hour, and things that are traveling in the low Earth orbit region are traveling at 17,000 miles per hour. So, you know, one tiny grain of sand can do some serious damage to a solar panel.
I would never even think about that. A tiny thing like a grain of sand being able to do damage.
Yeah, and now going back to what I just mentioned about this Cosmos 482 satellite, we were unable to predict the exact location where it was going to re-enter just because of the uncertainty and our thermospheric models. So
Wow. One thing, I'll shift gears again a little bit on you if that's okay. I've always been curious about, and I think I've read an article with something called moon illusion.
oh yeah,
About how when the moon is near the horizon and you're looking at it, it tends to look a lot bigger than when it's up in the sky. And it sounds like scientists still are not exactly sure why that is. Do you have any thoughts on that?
yeah. This is just an optical illusion. So the moon itself is not changing shape. But when you have some kind of frame of reference that's very far away, so you might see the moon rising over mountains or some buildings in the distance, the moon looks really big. But when you look at the moon way up in the sky, this vast sky, it looks smaller than it usually does. And you can actually do an example, like you can try and cover the moon with something like your thumb or something. Of course, you have to keep it the same distance away from your hand, and then go out a few hours later after it's risen and see it has not changed size.
So that's a good way to test it.
Yeah.
Okay. Sometimes I think people will confuse that with like a supermoon, which actually is a little bigger and brighter.
Yeah.
Sometimes detectable, sometimes not, right?
Yeah. So I think there's a lot of excitement about the supermoons, like as they rise, like, okay, the moon is really big, but then it gets up in the sky and okay, it looks kind of the same as it does. But one thing that is kind of interesting about looking at the moon rises is the moon will look more reddish or orange when it's on the horizon due to the scattering through the atmosphere. So the atmosphere, due to Rayleigh scattering, like the reason why our sky is blue, is going to scatter more of the shorter wavelengths off of the moon, and so the direct wavelengths that are coming to your eye are more in the red and orange.
That's so cool.
Yeah.
Let's talk briefly about social media. I mean, this happens with weather too. It probably happens in your field. I feel like there's costs and benefits. Benefits are that social media can be used for education. It gets people's attention. Hey, this really cool thing is going to be viewable tonight. But I also sometimes think that it exaggerates things and leads people to false expectations. What do you find when it comes to social media and space and things like that?
Yeah, I mean, it's great because it's such easy, quick access to information. There are a lot of scientists and engineers who use social media to try and educate, and obviously there are benefits, but we also have this problem, and something that has been brought up with the auroral displays is there's a lot of AI generated images out there, things that aren't real. Talk about hype, people thinking they're going to see something that they're not really going to see. One example that I've been using recently is talk about the white aurora. And that is actually a term that has been used in a scientific paper. If you look up and there's a whole lot of aurora occurring, your eye or a camera views it as white because you're getting a mixture of colors. But you might see on the internet and on social media these AI-generated images of white aurora, and that's an example of where social media has not done a great job of educating the public. So
for sure, one thing that comes to mind for me is I think a couple of weeks ago there was like a smiley face that was supposed to be viewable, and it was a combination of, I can't remember, planets and maybe a sliver of the moon. And the social media post made it seem really obvious of a smiley face. What ended up happening was like a kind of smiley face. So sometimes the truth sort of lies in the middle of these things, it seems.
Yeah. So
another thing I wanted to touch on was, and you mentioned this before when looking at the northern lights and photographs, sometimes if you get a great viewing with your own human eyes, the colors can be amazing. But obviously sometimes you have to be careful of people adjusting their exposures and pictures, where their picture might look beautiful, but in reality maybe didn't actually look like that.
Yeah. So this is an interesting one, right? Because I'll tell you the story. The first time I saw the aurora, it was actually very faint, and it was like this faint green cloud. I'm like, I went home. It was doing some research in Greenland, and I went home and I'm like, the aurora, they're all made up by pictures and everything. And I didn't know. I thought like, oh, it's all camera tricks. And the truth is, like, when you are this far south, if I wanted to take a picture of that, or the picture I took of the aurora in South Phoenix, yeah, it shows up pretty well on your camera. I was like, oh, I see this cool green or this cool red. But your eye doesn't necessarily see it when it's that weak. But I will say, the aurora, the real northern lights, the ones that you're going to see very far up towards the auroral oval, the polar regions, they are really that cool. They are. So don't be dismayed. Don't say, oh, it's all photo tricks. They are really, really neat.
Funny you say that this is years ago, 6-7 years ago. I took a trip to Iceland, and we went out to look at the northern lights. And the people that were giving us the guide did warn us this is not going to be a great night. And we saw kind of these white wispy colors. So I was a little disappointed. But then in the group were people that were taking pictures with their phones, and then they did something to it where it looked beautiful, green or all these different colors, and then they were texting it to their friends, look at this. And I'm like, come on, man, that's not what it looks like up there. But I think in that part of the world, I just happened to be there on an unlucky night, because I've heard, sometimes you can get just beautiful colors in reality up there.
Yeah. And so that's all. That's the thing. Like, it's hard sometimes to judge from social media what you should be seeing versus what is reality.
All right, finally, is there anything notable that we can look forward to seeing over the next few months or this year?
Oh, well, we are coming down from solar maximum, and I will say the some of the larger historical storms have actually happened just after solar maximum, so there may be an opportunity to see more aurora, but it's one of those things where you never know. You never know.
Just much like the weather, right?
Yeah.
Is there anything else that we haven't touched on that you want to add? And there's no pressure to add anything. I didn't know if there's any topic that we hadn't explored that you want to get into.
Yeah, I don't know. I guess also keep your eyes out for really cool space launches. And yeah, I mean, it's definitely a topic to kind of think about more, as we're utilizing space more. This can be from getting better space weather predictions to help astronauts in space, because we're talking about all of these really neat missions to the moon and possibly to Mars. We want to be able to predict when there's huge coronal mass ejections, because astronauts in space further out are not necessarily shielded by Earth's magnetic field. And also, I wanted people also to be aware of this growing space debris that is going to increase, and we are going to be seeing more space debris entering the atmosphere. There's a whole group of people tracking, like, oh, I see the space debris. Now instead of looking for meteors, where we've got people that are trying to track reentry of space debris, because it looks quite similar. And also questions about how the space debris is going to impact our low Earth orbit region, but also how that increased entry into the atmosphere is affecting atmospheric chemistry. So, yeah.
And are there any, and there's no pressure to answer this, any websites you want to mention to people, either your own or other websites you'd like to follow so they can get more information if they want to continue to stay updated on these things?
I think, the one that I always direct people to is the NOAA Space Weather Prediction Center, because they've got the best models kind of on top of everything. There's a lot of space enthusiast sites out there as well, but that's kind of my go-to favorite.
And my go-to resource is you. And I'm sure over the next few months when I get questions about this, I'll call you in a panic. Hey, can you come on TV and be interviewed about this? Because, that was nice to have you last time. So I'm sure you'll be seeing Katrina on our airwaves here over the next couple of years, if that's okay with you.
Oh, yeah, sure, anytime.
All right, well, thanks so much for joining us on the podcast. It's been a real pleasure.
Thank you.
All right, bye, everyone.